Welcome back. So now today we will discuss a single phase AC supply is given to RL series circuit, single phase AC supply is given to RC and RLC series circuit. For all these three you should remember these are the conclusion points. So we will define voltages, currents, voltage triangle, impedance triangle, power triangle and instantaneous power equation, waveforms and average power. So coming to the first one, a single phase AC supply is given to RL series circuit. We are given the instantaneous value of the voltage V is equal to Vm sin omega t. Then the current leaves here. The current flows through this entire RL series circuit is the total current I T bar, and the current flows through R is IR bar, and the current flows through L is IL bar. In a series we know that I total bar is equal to IR bar is equal to IL bar. So this is the first relationship. And when the current which is flowing through R, which will produce a drop, that is VR bar. So I am taking for a positive of cycle, always the current flows from higher potential to lower potential, and here also plus VL bar. So the instantaneous value of the voltages are represented with small letters and the phasors are represented with capital letters. Since here the current which is flowing through all the elements is same, that's why I am taking the reference as the current. Says I total bar is equal to IR bar is equal to IL bar. Yes, as per our requirement, voltage equation is there and the current is also defined. With respect to resistive current, the VR voltage will be in phase component. The VR is in phase component. And with respect to the inductive current, the voltage across the inductor is leading. VL is leading. Always inductive current is lagging. With respect to VL, IL is lagging by 90 degrees. If I am taking the inductive current is the reference and the VL is leading. So now V bar is equal to VR bar plus VL bar. By adding these two vectors, by using a parallelogram concept, then we are getting the total voltage. Draw a line from this, draw a line which is parallel to VR. The length is also equal to VR. Draw a line which is parallel to VL, and by adding these two vectors, then I will get the total voltage, that is V bar. The angle between the V bar and I, that is called the power factor angle. So from this the first triangle is formed, that is called the voltage triangle. Voltage triangle. So VR is a horizontal component and VL is a vertical component and hypotenuse is V. The angle between voltage and this VR is a phi. So where phi is called the power factor angle, So that is the angle between the voltage, resultant voltage and current. So from this cos phi can be defined as it is the ratio of VR to the V, the base component to hypotenuse. So sin phi is opponent by hypotenuse, VL divided by V. So sin phi component is VL divided by V. And V is equal to VR. So this is in the positive imaginary axis. If you take real axis and imaginary axis, and this is a positive real axis and this is a positive imaginary axis, so exactly 90 degrees leading. So VR plus J times of VL. So from this we have a magnitude V is equal to under root of VR square plus VL square, and phi is equal to tan inverse of imaginary part by real part. Phi is equal to tan inverse of imaginary part by real part. This is about the voltage triangle. So coming to the next triangle, that is called the impedance triangle. How we are getting the impedance triangle means, what is VR? So the VR is equal to I into R, and the VL is equal to I into XL, and V is equal to, we can define that is that Z is impedance, where XL is called the inductive reactance, R is the resistance, and Z is the impedance. If I am taking I is the common and cancelled out, then the horizontal component, the base component is R, and this one is XL, and the hypotenuse is Z. Now we can read it as Z is equal to R plus J times of XL. Y plus J means it is 90 degrees leading, and this vertical line is in the positive imaginary axis. So if you want to find out the magnitude of the impedance, under root of R square plus XL square, and the angle, phase angle, is equal to tan inverse of XL divided by R. So we can write it as magnitude of the Z at an angle of plus phi. So this is in the polar form, and from this voltage triangle, and this is the impedance triangle, we can get power triangle. So how means, there are two methods. So from this voltage triangle, this is VR, and this one is VL, and this is hypotenuse V. And from the impedance triangle, Z triangle, the base component is R, opponent is XL, and this one is Z. And here multiply current with all the terms, and we know that active power is equal to VR into I, and this we can write it as active power, and this is a reactive power, inductive reactive power, and S is the apparent power. VR into I. So cos phi is equal to the base component VR into I divided by V into, so VR into I, so VR into I divided by VI, and from this VR we can write it as V cos phi. It is a horizontal component, and sin phi is equal to VL divided by V, and VL is equal to V sin phi, and the substitute here, then VI cos phi. So this power is called the active power, and the units are watts, and sin phi is equal to, sin phi is equal to QL divided by S, or QL divided by S is VI, and from this QL we are getting VI sin phi, whereas QL is equal to VL into I. So what is a VL is equal to V sin phi. So this power is called the reactive power, inductive reactive power. And this power is called the active power. The units of reactive power is var, volt ampere reactive, and last one, that S is equal to V into I. We can write it as P plus J times of QL. So again the same story, it is 90 degrees leading. the magnitude of S is equal to under root of P square plus QL square, and the angle is tan inverse of imaginary part by real part, and power factor we can define as it is the ratio of active power to apparent power. From the impedance triangle we can define as R by Z. The power factor can be defined as R by Z, and VR divided by V also, where cos phi is called the power factor. And so by using impedance triangle we can derive the active power. Generally power is equal to VI and I square R. VR into I, that is I square R. So multiply I square term to the impedance triangle, then I will get the active power, reactive power and apparent power. So P is equal to I square R and QL is equal to I square XL and S is equal to I square Z, and the units are watts, and here it is volt ampere reactive, and the units of S is called the complex power. What is the S is called the complex power, and the units of S is volt ampere. Units of S is volt ampere. Here Z is called the impedance and Z is the impedance. XL we already derived when a single phase AC supply is given to L. So this is inductive reactance. So impedance triangle is over, voltage triangle is over, and the next one is instantaneous power. Instantaneous power. So power is equal to, it is the instantaneous value of the voltage and instantaneous value of the current. So this is a current and the voltage is leading at an angle of phi. So V is equal to Vm sin omega t. So as we are giving the supply voltage as Vm sin omega t, so the phasors are rotating in this manner. If I am taking the voltage is the reference, the current is lagging at an angle of phi. So I can write it, the current equation is Im sin of omega t. Lagging means minus omega t minus phi. So Vm into Im sin omega t into sin of omega t minus phi. So Vm Im into cos of A minus B means omega t minus omega t plus phi. So minus, right, minus cos of A plus B 2 omega t minus phi divided by 2. So cos of A minus B minus cos of A plus B is equal to 2 sin A sin B. I am using this formula, then I am getting like this: Vm Im by 2 into cos phi minus cos of 2 omega t minus phi. This is called the instantaneous power. Instantaneous power. So if I am applying voltage and current, instantaneous value of the voltage and current, I am getting the instantaneous power. So V is equal to Vm sin omega t and I is equal to Im sin of omega t minus phi. If you want to draw the waveforms of voltage and current, so this is a voltage waveform 0, pi by 2, pi, 3 pi by 2 and 2 pi. at omega t is equal to pi, at omega t equal to pi, then only the current value is 0. Im sin of pi minus pi is 0. Means the waveform will be started at pi. It is lagging at an angle of pi, that may be 30 degrees, 45 degrees, that depends upon the pi only. So I am taking the small angle. So this is a waveform of current which lags the voltage. See, this angle is pi, is called the phase angle. This is the waveform of current. The current lags at an angle of phi. Again, if you want to multiply the waveforms, first find out the zero position. Here it is 1, 2, 3, here it is 4, and it is 5, now 6. At zero position, if you multiply any value, the value is 0. In between zero position, what will happen? You can see. So here the voltage waveform is positive, but the current waveform is negative. Positive into negative is negative only. The positive into negative is negative. So I am getting the waveform is like this. Here positive into positive is positive maximum, and again here third position it will be 0. You can add the waveform is like this. And between 3 and 4, if you observe, the current waveform is positive, but the voltage waveform is negative. I have a small portion of negative waveform. And at this position between 4 and 5, if you observe negative into negative, that will be more positive. It will be more positive. And between 5 and 6, so between 5 and 6, this is a continuation of the waveform. So positive into negative is negative. So what is the time period of the waveform? Here it is 0 and it will be pi. Means the time period of the power waveform is pi. So now you can calculate the average power. 1 by pi integration of 0 to pi P instantaneous power into d omega t. On x-axis I am taking a d omega t. 1 by pi integration of 0 to pi. The instantaneous power is Vm Im by 2 into cos phi minus cos of 2 omega t plus phi. So Vm Im by 2 is a constant. Vm Im by 2 pi cos pi integration of 1 is 1 theta is theta only, omega t minus integration of cos of 2t plus 5, that should be equal to sine of 2t plus 5 divided by 2. Similarly here also sine of 2 omega t plus 5 divided by 2. Zero to pi. If you substitute the upper limit, and lower limit, this is 5 minus 0, and this is the sine of 2 pi plus pi minus sine pi divided by 2. If you observe that this term is 0 because sine of 2 pi plus pi is sine pi minus sine pi. This value is 0. Then Vm into Im by 2 pi cos pi into pi. Pi will be cancelled. Then I am getting the average power Vm Im by 2 into cos phi. So Vm by root 2 into Im by root 2 into cos phi, then the average power for RL series circuit is Vi cos phi. The units of this one is watts. So check this. First of all, we are representing the voltages. Yes, V bar is equal to VR bar plus VL bar. Then currents I is equal to IR bar plus IL bar. Then voltage triangle. Yes, voltage triangle is over. Impedance triangle is also over. And then we are deriving the power triangle, different power. And after that, instantaneous power. And then we are going for the average power. The average power formula is very important, and this is repeated in so many times. The average power proof, average power is equal to Vi cos phi. So derive the average power for RL series circuit. These type of questions will ask. Now the average power is finally Vi cos phi.